Hello, this is Mr. McMurray, and this is our second lab that we have for, I believe, Unit 4 we're on. But anyhow, for solutions, we're going to talk about paper chromatography. Okay, this is one of my favorites and what I used to always do in person, so this will be a good one for online as well. Okay, we're going to talk about chromatography. Chroma means color, graphy means to write. So basically it means color writing, but basically separating out different colors with a solvent and paper, basically, okay? Now, it will talk about some stationary phase, which is generally speaking the paper, okay? It's not going anywhere. And there will be a solvent moving up the paper, and that will be the mobile phase or just the solvent, okay? And so you can be any different. Sometimes it can be done with acids or bases or salt water, water, and so forth. Okay, salt water, I believe, is what they used in this one. And you can use all kind of different dyes and stuff like that. So really it has to do with how well does the solvent dissolve it, because there are two things happening here. For example, here you go. You start off with a piece of special paper called chromatography paper. You could do this with other things. Tie-dyeing is kind of the same thing as this, but with a t-shirt instead of a piece of paper. All right. If you've ever you're writing on a homework assignment and all of a sudden it got wet and the ink all smeared, that's an unofficial chromatography thing there. Okay. This special paper, you have a baseline where you put the dot to begin with. Okay. And then you stick it in a beaker where the water level is down here somewhere. So the water begins to move up the paper. Now, there are two things that are happening here. One is the solvent can attract or dissolve these solute, the ink dye here, and carry it with it. But it's also the ink dye is attracted to the paper, okay? And each one's a little bit different, whether they want to be attached to the stationary phase or paper, or if they want to be carried along with the solvent. And this causes them to travel different distances up here. So after a while, we stop it. Where the solvent went, it's called our solvent front. That's how far it went, okay? And here's, in this case, we just had one color of ink, all right, or dye in this one, all right? Now, no matter how long the piece of paper is, it will consistently go the same percentage of the way up the paper if it's done properly. All right. So what we really want to know is the percentage of how far did the dye move compared to how far the solvent went. All right. So we put the distance that the solute, the dye, the ink, went up here, and we divide it by the solvent front. Okay. If it went all the way up there, then it would be 100 or 1. All right. If you divided that, you could put times 100 here to make it like 100%, but we won't worry about that. Leave it as a percentage to be 1, all right? And most of the time, if it doesn't go up there, it's going to be somewhere less than 1, okay? Now, so you're going to have to measure the distance from the baseline to the solvent front and the distance from the baseline to the top edge of the solvent, all right? And so you get these two numbers, and then you will divide, and that will give you what we call your RF value, but we'll just call RF for short. Okay, don't worry about that. But anyhow, that's the RF value. Okay, the retention factor, meaning how well does it retain to the paper, I suppose. But anyhow, I just call it the RF value. So we got to go with that. All right, it's going to ask you a little questions about that first. Think about it. You have a couple of submissions for most of them. So I'll give you a couple of submissions. This one only has one, saying, if we really figured it out or not. Okay, whoops. All right, and then we're going to go to the real thing and do our experiment here, okay? And so basically they're going to let these go through, and they're going to separate into their different colors and so forth, okay? Now, each one of these only has one color of dye. So once it gets to the end, let it go ahead and go to the end. Okay, I'm not going to right now, but you need to know that. Let it go to the end, okay? And you're going to measure by using our tool things. First time we've used the tools. So click on the little tools here, and you get a ruler, okay? And the ruler is going to allow you to measure how far it has gone. Now, like I said, you're going to let it go all the way to the end. I'm not going to do that, okay? But I would put the 0 right on the little dot in the center of each of these that you can see where they originally put the dot, and then you would measure how far. Okay, notice they go up by 2, so this little dark line in the middle right there would be 1, and then 2, and 3. That one it looks like the yellow is about right at that. Okay, once again, you may want to put it on large screen so you can see it a little better, see exactly where the lines are. Okay, and you would put how far the dye went. Okay, I just put some numbers in here. They are not necessarily correct, just for the record. Okay, you'll put your numbers here. Now, then you will take, okay, you will measure how far the solvent went. In this case, it'd be about 2.9, it looks like. 2.9 is how far the solvent went. That goes here. And then you will divide this number by that number and put that answer over here in the RF value. Okay, now, these are, I assume, in order. I'm colorblind, so I'm probably not the best person to ask. But okay, so pink is here, then you have red, orange, then you have orange, then you have yellow, then you have green, and then teal, and then aqua. Okay, green, teal, and aqua would not be good ones for me. But a little bit later, it talks about the blue-green colors. That would be these last 3 colors, I'm assuming here, the green, the teal, and the aqua. All right. All right. So once you've done that for each of these, you put the RF values over here. I'm going to ask you which one had the greatest attraction to the mobile phase, which would be the solvent, which one dissolved the best and moved up with it. Okay, and then it's going to talk about the green dyes and say, does this work very good for them? And then good news is this one has been eliminated. It will not be there, so you can skip that. All right, it won't, actually, it just won't be on your final copy. Sorry about that. All right, then you will get an unknown mixture, which has several of these dyes on it. You will let it begin to separate. Okay, and once again, you let go all the way to the top, or at least to the end of the video. Okay, and then you're going to do the same thing, get the ruler, and for each of the different colors, you're going to, the solvent front will be the same for all of them, because wherever it stops up here, and then you will measure for each of the separate colors that are in it. Okay, so here you put the name of the color, the dye, how far the dye went. All of them will have the same value for the solvent distance. However, far up the screen, they let the solvent go. And then once again, you would divide this one by that one to get this number. And then by comparing these RF values to the RF values up here on your chart, you should be able to say which colors, this one here, you should be able to say which colors you think these colors here are. Okay, and that's basically where you write your conclusion here. All right, you explain how you identified the 3 dyes. Was it effective? Does your RF values you got on this one agree with the RF values on the first experiment? And then talk about, well, how could it have been messed up, or how could it be done better, or what may have caused problems. Okay. Other than that, I think that's pretty much it. So enjoy and get out there and do some color writing.